Okay, well, thank you very much. I really appreciate the invitation. It is with a bit of trepidation that I'm up here, because I'm not a scientist. I think I'm the first speaker that's not a scientist, and but I think I'm with you. How many people here are not scientists? That's most of us. Okay. I am a journalist, and I have been tracking climate change now for 6 years. And my background is a natural history photographer, a lover of the earth, and someone who has followed natural history science for most of my career, which is about 30 years now. I had a sort of a baptism by fire in my active career as a nature photojournalist. I lived very near Mount St. Helens in 1980. I was lucky enough to get up there and be on the safe side of the mountain. And I have continued to follow this mountain thanks to magazines like Life magazine, who commissioned me to make these pictures of the recovery of the mountain. And so along with that kind of violent change, I'm also the kind of person who watches out for gradual change, in this case the recovery of the landscape beneath Mount St. Helens. At first I thought it would be barren for many, many years, but within even 10 years, every species of every kind that was there before was back. And it's recovering now, and I'm continuing to follow it. I've also been lucky enough to cover a lot of the biomes of the world, the tropical forests, tide pools, and of course also to photograph the depredations and the use and overuse of the planet by humans. So when I began to read about climate change, it became obvious to me that there was a story here that wasn't being told very well, at least visually, and I decided to try to do it. This came about primarily from a trip to Alaska, and I photographed the great caribou herds. This is the Porcupine caribou herd on their migration. This is the herd that lives in the Arctic refuge and might be endangered from oil drilling in a certain part of that place. But while I was there in the late 90s, within a few hours I flew from the pristine shore of the Arctic refuge to Prudhoe Bay. And this kind of difference on the same kind of landscape woke me up to one part of the story about our energy use and what we were doing to the planet. And the other part of it came about with information from scientists up there who said they were beginning to see global warming's effect in Alaska on the ice and in the tundra. And so with an eye seemingly on me by the caribou, I began to try to photograph global warming. Now, along the way, not being a scientist, although I am a graduate of college, I have a master's degree and so forth, and I read science very well, but there's a lot of technical stuff in the study of this. But this is another version of that graph that we've seen so often of CO2 and methane against temperature. And this is put together by Jim Hansen of NOAA, or NASA actually, and again showing how far we have come in our current century above the levels we've seen in many, many hundreds of thousands of years. And I assembled this with some help from Scientific American. This is comparing the rise in CO2 recently in this century and the end of the last century of the 1860s and so forth with temperature being very uneven from year to year, but making this very familiar curve. But also there are a lot of sites out there on the web that are showing other graphs that are complaining this is not good data, that are parsing the data everywhere else. And I frequently had to go to the scientists themselves to find out. I've learned there are some correlations between temperature change and events on Earth that do not work. And I've also learned that in terms of the climate models that we've been hearing so much about, climate models are also all over the map, as it were, and you have to be very careful. This is really heavy-duty math. My favorite climate models are the ones that show up at the anti-global warming rallies in Washington and in Hollywood. So these are my climate models. Okay. Now try not to think of them next time somebody shows you a graph of that. Right? Well, but in beginning my project, I realized from my other work that we live on a very highly integrated, highly evolved, interrelated planet. The continents and their life zones are interrelated with the oceans. There's an incredible ebb and flow of energy, and these processes and these animals and plants have been evolving for many thousands, if not hundreds of thousands or millions of years. And it's a daunting thing to think about this system beginning to change on us. Also very daunting to think about trying to travel around and photograph the places that are changing. I also realized that the human footprint, imprint, on the Earth is very heavy. This is from the Human Footprint Project and other things. Globio is one of the UN organizations making maps of human effects on the planet. The red marks are where humans have had an overwhelming effect or are present. You can see a lot of green, untouched areas in the north, and of course the Amazon basin stands out. But we have been very busy as a species. And we've also been busy in the oceans. This is a map, much more crude map, developed during the recent studies, the ocean commissions, showing the areas of the ocean that are beginning to be depleted of fishing stocks, of commercial fish stocks. That headline at the top, world's large fish estimated at 10% of their original population as of 1999 to 2000. The very serious effects that humans are having on the planet. And now overlaid on all of this is an effect of climate change, which we are at least partially responsible for. And I made no claims to know what was going on when I started my project. So I've traveled around the world from Australia and some of the Pacific Islands just north of there to China, to Bangladesh, into Europe, South America, North America, and Alaska, and tried to follow the science. I went to Antarctica, where Eugene Domack has been doing ice cores at the leftover remnant areas of the disintegrating ice shelves to try to understand what kind of climate change has happened in the past. And as we've heard before, ice shelves, which are floating, are disintegrating in Antarctica, especially on the peninsula. And this is beginning a sort of a cascade effect, releasing a lot of the land-based glaciers in the peninsula of Antarctica to flow faster toward the ocean. And these land-based glaciers will raise sea level. We've already heard a bunch about that. There's also studies going on in the Antarctic Peninsula about penguins, and this basically has to do with the fact that the Adelie penguin, anyway, has a relatively narrow range of acceptance in terms of where they put their rookeries. And when the climate changes and there's too much snow because the air is warmer, or when the ice goes out too far because they hunt under the ice, these rookeries change. And Bill Fraser here has been tracking these changes for almost 30 years now, and actually can draw a line across the Antarctic Peninsula as the penguins have reacted to climate change in Antarctica. In Greenland, we've already heard a number of displays of this. Mark's very interesting and enlightening figures about that last year was the greatest year of melting on the surface in Greenland. This is the southeast coast of Greenland, and here's a closer look at one of the glaciers that's moving the fastest in Greenland. And then this is the outlet of the Jakobshavn, which is perhaps the fastest moving glacier, which Mark showed us some pictures of. Incredible output of icebergs, and this seems to be accelerating. In the Arctic, along the shorelines, there is frequently in the summertime less and less ice, and the primary mammal that this is affecting is the polar bear, which is the largest land carnivore, but in fact the polar bears are really more like marine mammals. They don't belong on land. They live in and on the ice, and they den up on the ice. So it's really not good for them to be having to hunt on dry land. And as we found out a couple of years ago when there was a sighting of bears that actually had drowned in the Arctic Ocean, apparently trying to swim too far from ice floe to ice floe, we know that it's not good for them to have open water either. And so this is one of the major mammals that is beginning to be affected heavily by the warming in the Arctic. A lot of studies going on in the Arctic about what's happening with climate change. This is Walt Oshel, who actively measures the flow in and out of carbon dioxide and methane in real time. He knows exactly what's happening up there, and there have been changes. It is more of a source of greenhouse gases now, but it actually was more of a source in the 80s. These are very complex studies, and thanks to him, we're getting very detailed information. This is Tom Osterkamp, who has put holes down into the permafrost across Alaska, and his data is among that shows that permafrost is thawing, is what's called thermokarsting, is beginning to melt at the surface and not refreeze, and that permafrost, the temperature of it actually is starting to get higher across Alaska. Now this has very severe effects on native villages that live on permafrost, and this is another view of the village I think that Mark showed. This is Shishmaref, and this is a village of about 500 Inupiat that has decided to move from a place where they have come hunting and lived for many thousands of years. The town has only been there since about the 1940s, but it is their place of hunting for seals and so forth, and they're going to leave it because it's intolerable for them to stay there as every year more and more of this cliff face on which their town is built erodes away. On the other side of North America, on Baffin Island, there's a town called Pangnirtung, again an Inuit community, and they're suffering from much warmer seasons. They have dust storms. They've never had those before, at least in the memory of the elders, and very severe changes to the lifestyle and the hunting of the natives of the north because of all of the changes in Alaska. Because I've been photographing quite a while, I can see changes in my own landscape. This is Mount Hood, my home mountain, and the changes that you see here from 1984 to 2002, I had them checked out by Andrew Fountain of Portland State University, a glaciologist, and it is reflect what it seems to be. The glaciers are getting smaller, and in fact the onset of snow in the winter is delayed. So even in my own backyard, on a very steep Cascade volcano, we're seeing a loss of glaciers. As Lonnie mentioned, I have been tracking glaciers and going around the world. I just want to show a couple here because we've seen a number of these, but this is my latest one. This is the Athabasca Glacier in Jasper up in Canada. It is one of the most visited glaciers in the world. And along the way in my project, I switched from any glacier I could get an old picture of to try to focus on glaciers that more and more people have seen in their vacations and so forth, because I think this is one of the things that brings it home to people. The glaciers in Glacier National Park, the glaciers in the Alps, the glaciers in the Rockies of Canada. These are our hometown and very beloved landscapes that are changing right before our very eyes. Thanks to some people in New York City, a little exhibit, I was able to put together a poster of some of these changes. And I don't need to tell you where they're all from, but one after another, glaciers around the world are shrinking very rapidly. I have some of these out at the bookstore. And down in the lower right, you can see my method, basically eyeballing an old picture, trying to get in the right spot, and then make a repeat shot that tells the story. But all that water that's going in is raising sea level. As it's been mentioned a couple times now, there's an ongoing feeling that the amount of water coming off land glaciers is beginning to overtake, or at least rival, the amount of sea level rise from just the warming of the ocean itself. And so I went to some of these places that were affected by this, and one of the most famous in the news a lot is Tuvalu, which is a tiny atoll in the Pacific Ocean, north of Fiji. You get there actually on old prop airplanes. It's sort of like the way you used to get into the north of Alaska 30 years ago. That's still how you get there. these people are very much, in a way, like the natives of other parts of the world. They are modern people, but they still fish and so forth and get substance from their land and grow their own food there. But every year, especially in certain cycles, the tides are higher. They come in higher. They're higher on the rising sea level, and so they have more and more flooding of their infrastructure. This is becoming a common event there, and they now have a program with New Zealand for approximately 75 Tuvaluans to move to New Zealand if they wish to every year. It's sort of a slow migration away from a place. And it's not so much just the tides every so often. It's the fact that these tides bring salt water into their fields. And the really big danger, of course, is that a large storm will come in at an extra high tide and cause incredible damage that wasn't there before, that they hadn't experienced before. I went to Bangladesh. Bangladesh, of course, 140 million people. It's probably the most populous nation that is beset by troubles from climate change and sea level rise. Tuvalu was only 11,000 people. And I went there specifically at a time, if I could, when there were no storms, the rivers weren't flooding. This is just sort of the normal level. And the people who live in the villages down in the Great Delta, where Bangladesh is built, are saying that there is increased erosion of their villages, which happens anyway, but they say it's increasing in the last number of years, and this would correlate with increasing tides and more ocean action coming up from the Bay of Bengal. This picture I found particularly poignant. There are approximately 85 Bangladeshis standing there on the ragged, eroding edge of the road going to their town. Those guys, on average, by the whole country, use about as much energy per year as one American. And so this has sort of double meaning for me about the dangers. You can see they're not very far away from a 1 meter sea level rise, which is expected to be very possible by the end of this century. A half a meter will make the erosion quite a bit worse, as you can tell. But they're not the only ones at risk. We are at risk in this country. We don't have to talk about this the way we used to, saying this is going to happen, because it did happen. Even though the story about Katrina is more about infrastructure failure and political failure and the social costs of an old system. But that's exactly why global warming is so dangerous. Global warming interacts with all of our other systems, all of our other troubles. It interacts with how we get our energy, where we get our water, and the relationships between nations, and the relationships between different parts of the country. And it's going to make a lot of these much worse unless we can get a grip on it. That's the Miami area, of course. I wanted to show this. This is very interesting. This is from NOAA, and it's a combination of sea temperature and storms in the Caribbean at the beginning of this past hurricane season. You can see the date down there, June 25th, it says now. And they track, you see, as storms go, they follow them with a line. You can track them. So we're now in July. And notice how the warmth, it's indicated by a red color, is coming more and more into the Caribbean this past summer. And it gets warmer and warmer, and there's quite a large hurricane, which I don't happen to know the name of. It went into Mexico. But coming up in August, one will form right off of Florida, and it's going to cut across toward August 7th now. You see how this is very interesting to me to see how this interacts with all of the weather systems. So right about in now, you're going to see a storm come up just off of Florida. There it is, crosses Florida, becomes a Category 5, and that was Katrina. To take a little close-up of that, this is Katrina. This is a GOES satellite image of the storm overlaid on a map showing sea temperature. And the sea temperature in the Caribbean was 2 to 3 degrees higher than it had been before this past summer. There was a lot of coral bleaching in the Caribbean. And of course, at this point, this is the beginning of the 27th of August, Katrina was coming very rapidly into Category 5. Of course, when it hit, it was back down to a Category 3. But the strength of these hurricanes, there are now, I believe, 4 studies that by various methods tie increasing hurricane strength to warming seas and warming atmosphere. The number of hurricanes is changing on an independent level, but they do appear to be getting stronger or have the potential to do so, and that's why this is such an important the kind of synergy, the kind of feedback system that global warming gives us. This is Florida, of course, and the orange color is 1 meter sea level rise, which may happen by the end of the century, but more likely is 0.5 meter, and that's the dark red. And there are going to be a lot of changes on this shoreline, just as there are happening all along the seacoast, wherever there's beaches. The incremental change in sea level and possible incremental change in strength of storms is eating away more and more and more at coastlines. This is Cape Hatteras, 1999 above and 2004 below. Doesn't take long. Well, there are some things that we can do about rising sea level and more flooding. We could change our transportation mode. And, you know, a lot of time there's a lot of blame placed on Detroit for not giving us the right kind of vehicles that would do better under global warming. Well, you know, I happen to know there's a secret program going on at Ford to deal with global warming and the rise of sea level. So this is your SUV. This is your submersible utility vehicle. They are ready. They don't want to tell you yet. Well, more serious problems, of course, are happening in the oceans because the temperature of the ocean is going up ever so slightly, about 1 degree Fahrenheit, in some places a little more than that. And the danger there is coral reefs, of course, which I don't think we've talked about too much here. Corals are extremely important for nurseries of fish as protectors of shorelines and of incredible economic engines from tourism, of course. But if it gets too warm in the water, the corals have to expel their symbiont and they get white. It's called bleaching. And this happened extensively when the El Nino hit in 1998, happened again in 2002. And as I said, there was a bout in the Caribbean this past summer. This is happening right now. This was just a few weeks ago in Australia, the height of the summer there. And this is what bleaching looks like, formerly very colorful coral expel the little algae that they live with that carries the color, and they turn very white. And the problem is if the water stays warm too long, the coral will not recover. And you basically change to a more of a different kind of algae regime, and that basically reduce the health of the reef and the number of fish that grow there. And it's expected that if sea level or sea temperature continues to rise, that more and more times during the year around the world, temperatures will get above the level that coral can stand, and they will bleach, and more of them will essentially die. And this is a very serious problem. And there's another problem in the ocean, which was mentioned, I think, earlier by Bill, about the fact that there's so much CO2 being absorbed by the ocean that the ocean is getting just a tiny bit more acid. Just a natural chemical reaction of getting CO2 in water. And that means that every creature in the ocean, starting with the corals and all the mollusks that make a shell, may have more difficulty making the shells. And that has untold, just beginning to be studied effects. And one of the more dangerous effects is on the plankton itself. Many plankton species make shells. There's a micrograph of some plankton actually from the Antarctic Ocean. So these changes in the ocean, which are very little known right now, very little studied, are very, very important feedbacks that are happening that we didn't even guess about a few years ago. There are changes in tide pools and coastlines where species that are more attuned to having warmer climate, warmer water are moving north, and more cold water species are moving farther north. There are many, many changes in plants and animals. The most famous study possibly was Camille Parmesan, for the first time documenting the change in range of a butterfly. This is the butterfly, Edith's checker spot. There are documented studies now from the U.S. and Europe especially of changes in migration patterns, migration times, and nesting times of birds. In Alpine Zones, this is a crew from the Glacier study, which is a worldwide study of Alpine Zones. You can see the white markers that they have down. These were put down 10 years ago, and they've come back to remeasure. And indeed, many species of alpine plants that need that cold and that snow to survive, it's part what they were evolved to, are having to move farther up the mountain. And notice behind them in the Alps, these depleted glaciers, another sign of global warming. This is Alan Pounds, who works in Monteverdi, and he is one of the people who wrote a paper indicating that the possible extinction of a species of frog because of global warming. At first he thought it was because of just drying out, and now he believes that this and other extinctions in Central America of various kinds of cloud forest toads and frogs is caused by an interplay between climate change and a fungus that attacks the toads. This is a very complicated sort of a double correlation. I expect to see a number of papers looking at this more carefully and some back and forth among the scientists. But this again is a sign that the interplay between global warming and the whole ecosystem is what this is the most important thing that we have to be concerned about. Not just that it's getting warmer, it's what it's doing. The big indication of this is the fact that all around the world, plants, animals of all kinds, tend to be making the changes as you would expect that they would make in a warming world. And so that a study of many thousands of research projects indicated that, for example, on average, the ranges of plants and animals had moved north about 4 miles per decade, and that spring events like nesting and so on were happening an average of 2 days earlier per decade in recent decades. So this can be seen. This is what's known as the biological fingerprint of global warming. The plants and animals are doing exactly what you would expect them to do if it got warmer. You don't need the temperature, you don't need the thermometer to tell you that this is a worldwide event. This is a place I've been showing you that's in Australia. It is a range of mountains. It's a World Heritage Site. It has about 75 endemic species. Some of them are the remnants of the Gondwana life zone. As Australia changed its temperature, this tropical mountain range in Queensland became the last refuge of some of these animals. And it is now threatened, of course, by rising temperature, because all of these critters, the frog you saw, some of the ferns that you saw, and some of these nocturnal marsupials are on the top of that mountain because they require cool air. And as they get warmer, they have no place to go at all. And this is expected to be the scene of some extinctions in the coming years if temperature rises very much higher. This is Steve Williams' work, which was published in Nature, I believe, not too long ago. The big thing that I've learned from tracking these biologists and their sites and all their critters is that these banding of ecological zones that we became so familiar with in basic biology, the Holdridge zones, I look at it sort of like a big dress with lots of crinoline layers. And you can't think of it as just this lady with a crinoline is just going to get up and move all of them at once. They're not going to do that. What's happening is that each plant, animal, and of course the water and the glaciers together, they're moving at different rates. They're making slightly different responses. And so a lot of habitats are apparently going to disconnect, to fragment under global warming. And this includes the habitats that we've protected in the world's protected areas, the World Heritage Sites, and our favorite national parks. And this again is a very serious issue for management of the areas that we have spent so much money and time and political capital in trying to protect. They are frequently not going to be protecting the habitat that they were set aside for as global warming continues. Just a little bit about weather. I've been unlucky enough to be in some severe weather events. This is a dust storm that I ran across me, I should say, in Australia. A lot of violent weather events, and on average, There's a slight increase in the amount of rainfall in many storms. That is, the individual storms tend to be greater. There's more desertification. This is an incredible kind of event that's been happening for some time, is dust blowing off of Africa all the way across the Atlantic. The landmass in the upper right is Spain and Portugal. This was, I think, in 2000. There's a lot of interconnections between dust from Africa and the Caribbean Sea, and it's a very interesting issue. But these kinds of storms show some signs of getting more. There's incredible droughts that are being exacerbated in parts of Africa. And right here in the west, I don't have to tell any of you that there's a persistent drought. It's been some change, but this was last fall, a portion of Lake Powell. Definitely quite a large bathtub ring. This is a severe issue for water use, for recreation, and of course for the relationships between states and nations. The Colorado River Pact was signed when the water flow was at its highest ever, and now we have troubles. A big problem is coming in terms of forests around the West and everywhere in the world really, and that is that heat is persistent and winters are warmer, that insects are attacking the trees with more success, and whole forests are dying. And this is increasing the number of forest fires. 2005 was probably the largest wildfire area or time in the United States on record, and there have been record fires throughout Alaska, primarily in places where they had beetle damage. The implications for cities are pretty severe also, because in cities, heat waves, already been mentioned, the European heat wave that killed 20 or 25,000 more people than normally would die in a summer. This is a photograph of Chicago in 1995, which I just happened to take as I was in town. It was before my project, but this is when they lost almost 800 people to a heat wave. This is going to become more and more common. So that's why I went to China. China is the second banana when it comes to climate change. They will probably overtake the United States very soon. They use a lot of coal. They have a lot of pollution. They're having effects already of droughts and floods and loss of glaciers that's tied to climate change, according to their own scientists. They use an incredible amount of coal, and they use it very inefficiently. And they want to have more and more of their 1.3 billion people to be in the middle class. This is multi-millions of people wanting to have cars, refrigerators, larger homes. And this is the predicament that we're in. We're in a predicament of these kinds of vehicles without pollution control or with not high enough mileage standards or using, even any kind of petroleum engine are going to lead us into higher and higher climate change. And in the United States, oil is our important fuel for cars, of course, but coal is still one of our major ways of making energy. And in fact, as time goes by and petroleum becomes less available, coal will be our biggest energy source. And the problem with coal is that it gives off much more carbon dioxide per unit of energy. And the thing that makes me mad about the way that the United States gets coal is that we are now allowing companies to just shave off the tops of mountains, bulldoze them away, dump the stuff in the surrounding streams, and use equipment on the surface. This is called mountaintop removal mining. It's terrible. It should never be allowed. And this is one of the things that we could possibly reduce by changing the way we get our energy and the mix of our energy in this country. So we're going to have some talk from now on, I think, in the program and tomorrow about what we can do about climate change. I've been tracking that also, the Netherlands and what's called the Low Countries. They have a lot of history of flooding, and they have now a long history of using alternative energy, and they're countries to watch. Solar panels are coming along. Both of these sources, solar and wind, are more expensive now than they will be in the future, and they're growing very rapidly. This happened in San Francisco. This is the Moscone Center, their civic center, completely roofed now in solar panels. In Chicago, they put a garden on top of City Hall, and it's cut their electrical bills and their heating bills and insulates it, plus it's good for the air. And look at this cityscape in Chicago. There's no reason to me, except back expense and far-thinking owners and architects why you couldn't have solar panels every place you see a window, a dark window on all those buildings. I think this is the way we need to go. We have lots of roofs, we have lots of parking lots, we have lots of infrastructure that could be turned to solar power. Unfortunately, this is sort of our national energy policy. I don't want to say any more about it. I'm sure the other people will get into the politics. We're going to hear a lot about policy now, about how to change. And I think the most important thing that we can do is to unmuffle ourselves and start listening to what the possibilities are and see into the future about the energy sources that we have now that are not so intensive in carbon. There's no reason why most of our automobile fleet could not be hybrid cars right now. And I hope that everyone will go to their car dealer and start pressing on them. But I make a call to the dealers that are near me all the time and ask them when they're going to have more hybrid cars. It's only one person, but we are all in this together. And the important thing is to think that we call it global warming for a reason. It's crossing all borders. It's crossing all human endeavors. And that's why it's a serious threat, but also, as Lonnie said, an incredible opportunity to make a change that will be good in terms of our health, in terms of our human relations, and in terms of equality, and in terms probably also of just a quality of life eventually for everyone. So I have a website where you can see more pictures. It's worldviewofglobalwarming.org. And I'm working now with the University of California Press. The book is there. It will be out later this year with probably a launch early next year of a book based on all this work. I'm not sure it will look like this, but that's the title, Earth Under Fire, How Global Warming is Changing the World. And I'm ending my book talking about the positive changes that our reaction and the opportunity of climate change gives us to make changes that will benefit everyone. That's the way we should go, and that's the way we should look at this time that we're living in right now. So, thank you very much for your time.